So I think before we go there, I just wanted to recap certain things. I think that so that as I said from the start, you saw that I kind of wanted to give a bit of context why decarbonization is important, and then move to the LC as a topic, because that's my expertise, and I know some of the expectation is that power industry technology, etc. But whatever we do at the end of the day, I think technology evaluation is more important than anything else. So you need to have the appreciation and tools like LCA, technical mix. Increasingly, you will see listen to more these kind of things. It will be requirements for any proposal. So that's probably I've covered, and obviously I have quite a bit of experience with hydrogen. You maybe already realized, and I want to make the awareness a bit more. Hopefully, I have achieved that. So I'm not sure you have finished that questionnaire. So if the feedback, if you don't, please submit to Avash by tomorrow. So I'll collect that, and it helps us to improve the course, etc. So anyway, so the last topic, I just briefly mentioned you that whatever technology we do, we need to have some sort of recycling aspect, and that how you recover the material and put it back in the system so that you the end of life. You know that LCA, when I showed you the software, one scenario I didn't show you is called waste scenario. So any material, when end of life, they must have some sort of management. And waste means whether it is under a steel plant may have waste. Obviously, power plant have lots of waste ash. So at the moment you are kind of stockpiling it, right? From our ash pond, and then someone going to the cement. If there is any utilization, that's a very good thing. And then you replace the other clinker virgin material going to the cement plant, because you can kind of substitute and you get some credit for that. That's how it is working. So waste is important.
What we do with the ash after dumping in the ash pond? What is the utilization of that?
So they go to cement plant,
ash pond.
Piling.
Landfilling only.
Also landfilling, yeah. But is that ash which is going to the cement plant, do they have specific requirements for that?
That is only in dry mode they are taking.
Fly ash.
That also fly ash.
Like fly ash, okay. So for other ash is more landfill, not much.
Yes.
So I think as you kind of realize that and
we are exporting the fly ash.
is it? I see. Okay. Oh, that's interesting. Yeah. So that's right.
So
So
why it is called pond?
if there are options to
This is because
export
dumping in a
those
pond.
Dumping in a
materials to
pond,
other
that's
countries,
only, yeah.
that's even better, because you can probably globally, regionally, you are helping one. So with the waste material, I don't know, you are probably more downstream metal manufacturing. If you talk about the mining engineers or talk with the mining engineers, it is becoming a huge problem, because globally more material you make, more waste you make, and particularly gold mining. Actually yesterday I was saying that Churulia, that this is in Hanbad, I was going to Hanbad, and 20 kilometers inside that village, which is the birthplace of the poet, Bengali poet, that's why I went, but I didn't want to see that big, lots of, I saw that mines are also that, what they call that,
Dump yard.
rock dump.
Rock dump yard.
Huge, it's like a mountain, isn't it?
A mountain.
So it's that artificial kind of, isn't it? Because they are two, and even those times are what they call ratio, is maybe better material, less waste. Now it's a tailings. you have been heard of tailings, right? Mine tailings. Mine tailings is going exponentially. And you know
What is mine tailings?
mine tailings is okay. So let me explain that. Say copper mine. So we copper 1% and 99% is unwanted. So first you decide mineral ore. What's your background, by the way? Mechanical. So mining engineers, they learn first thing that ore and gang. Okay. So that ore and rock. So part of the rock is used to basically ore. What is a particular mineral? Even within ore and gang, which is unwanted. Ore means the minerals, and gang is unwanted essentially. So initially the amount of rock doesn't have anything, or even overburden they call it sometimes. You have to, and those you see generally either overburden or rock down. It's huge, okay? And even forget about that, maybe that's maybe say 70% gone. Within 30% ore, now you are dealing with the minerals and air. So your job is to extract minerals. So generally most of the iron ore and bauxite or aluminum is a little bit different story because the grade is high. But generally any other minerals, you talk about copper, nickel, manganese, majority of them what is called sulfide mineral, you have to do the mineral float. So basically what you do, you grind it and first you crush it. Primary, secondary, tertiary crusher, size reduction is called combination. And then you put in a ball mill where steel balls and the material becomes very fine because you need to separate or liberate the minerals from the air. So once you do that one, then that generally it is sulfide mineral and good to float. Then they put some kerosene in the mixture, slurry. It is probably 40% water, 40% solid, 60% water, and then you put some kerosene, put some air bubble through the underground. It's called flotation cells. So it's a kind of start the mixture, and you get minerals float, and rest of it sink. So because minerals is small amount, so you get like scum or some kind of top layer. It's like when you cook milk or boil milk and like a what is the top part froth. So that froth is collected and then that is dried and that becomes concentrate and that's sent to metallurgists like you. So then that is become metal. But already percentage of that material is small. Majority of the material sinks, which is unwanted, maybe 99% or at least maybe 80 plus %, because concentrate has got, so we started with 1%, we enriched to maybe 25% copper, that's for copper concentrate or similar with other metals, and then in that place you the flotation plant or they call it thickener. So when the thickener produce two streams, one is your product, other is unwanted material. All these going to the tailing pond, and that is water and all these other unwanted solids essentially. So that tailing ponds, you can imagine some of the tailing ponds you can see from the sky, even from the plane. It's huge, big mining countries, so Chile, South Africa, Australia, we have lots of issues like that, big tailing ponds. And what happens, nowadays lots of companies are doing called dry tailing. So basically less water so that you can store more tailings. But majority of the cases it's like a lake, tailing lake. It's a pond, that's why called tailing pond. So that's what is tailing. Answer your question? Now what happens? It goes like that and becomes like a river or a pond-like structure, and the solids saturates or sediment kind of deposits underground. So it slowly goes up. And what they do other side, there are many ways of tailing ponds. Because I used to teach mining engineers tailing management, and that's all the things I learned. I never knew that. So they goes up the wall, okay? And you can go up certain level as an engineer, you know that one. And in many cases, sometimes they fail. If they fail, the whole there are so many stories that
how you dump the material at that height?
So
the
material
height
is
is
deposited, and then you have got a kind of wall, retaining wall, which holds that tailing pond, but you can have a certain height. If you want that height, if you go, it will collapse, obviously, isn't it? Yeah. So now, because it's a very liquid and solid and kind of sometimes suspended, what they call that slurry kind of scenario, it sometimes collapse. Yeah. So it's unpredictable sometimes. So in Europe, in Brazil, there was big disaster.
A few years
BHP may probably have to pay billions of dollars as a compensation because not only are many companies, so telling them and telling them management is companies' law, very important thing. But unfortunately, there is no way out because you need more material, and every year more materials people are extracting, and telling them is becoming a problem. So that's a waste. But good thing that many of the cases, those wastes are not problematic waste, not there we call it, maybe some chemicals are there, but they also capture some of the chemicals during processing and treatment. So relatively, I would say just water and solid and clay and etc. But some cases, if it is hazardous, it is problematic. Say for example, uranium mine. Say for example, gold mine, there is cyanide, and then that may be mixed with tailing. So those issues becoming more under control now because lots of regulations, lots of scrutiny. But this is becoming big problem in mining industries. How we manage waste. So that's why less waste in any process is better. So I think, so that's what we're talking about. So in hydrogen energy, I want to show you, I talked a little bit about recyclability. So that's also good to be aware of. And just I'll show you a few things. So we talked about a cell, PEM electrolyzer cell, and obviously that's the membrane. Okay, that's your titanium plate. That's your cathode PTL or porous transport layer. Sometimes we use carbon paper. Cathode, iridium and ruthenium oxide coated anode, and also sintered. So you can see this is the exchange membrane. It's not the big one. It's called NEA. NEA is when it is coated, it's called membrane electrode assembly. And then you put that one, so that becomes a cell, and then you put it in a stack. That's sort of environment. Now you see that one, particularly is iridium, ruthenium, and even if you use platinum, those are expensive metals. Those are less available also in the world. So how to, even they use very small quantity as a kind of coated surface, but without that, that's a catalyst, you cannot break water. So you must have to have that one. So how we recycle that? So that's the discussion we can have. So you can see that one, iridium, ruthenium, platinum, gold, titanium, and iron, so about the steel. So in terms of criticality, all of them critical, and some of them gold is now critical in some countries, so they change depending on years. For that particular time, gold, generally gold is not critical. Titanium, but these are the critical minerals, and then another thing called strategic minerals. So that's probably I briefly mentioned. You want to have that, but the country has that one will not sell to you because of other reasons. So Australia, for example, have some critical minerals. I want to sell more than one kind of, special relation, etc. So that's called the strategic minerals. And without that minerals, you don't have a hydrogen technology. So what option those countries doesn't have that one? So you can have, say, electrolyzer, you buy it, you use it, end of life, say 10 years or down the track, when that it becomes a mainstream hydrogen economy, then obviously those materials will be available. So then you have your own stock. Can you recycle that? That's the discussion we're having to have. And then this, you can say these are in the globe in terms of availability. So there are lots of iron, titanium, lots of iron obviously, 85 billion ton maybe, 84 billion ton. Australia has about 30 billion tons, something like that. So Australia is one of the, Brazil have maybe, China, India. And similarly, if you go each of them, each country has those ones distributed around the world. And countries with largest river, you see that on exactly same. The board is Australia, we produce maybe 300 ton of gold out of 2,000 ton global production. So significant gold producer there. Titanium, China, South Africa, Australia, actually India should be there, I'm not sure, because India has got significant titanium resources in mineral sand. And again, Australia, Brazil, Russia. So you see some of the countries are pretty good, they have got, but another thing is called life of a metal, called used to not calculation like that, and used to monitor. So that is basically, this is only selected metals, but we can have all periodic table. We can know how much sort of in the world, and this is the price obviously, but iridium price you can see 1 kilogram is $1,000 Australian dollar, compared to iron is very low value product. So your obviously gold is $87,000 per kilogram. So there is a price value, there is a reserve value, reserve difference, price significant difference, an order of magnitude, and logarithmically some of them several hundred times difference. And so if we know that how much is there in the globe, how much every year is producing, if you divide this one divided by that means how many years will run out there. This is very simplistic. It doesn't take into account, for example, technological development. So at the moment maybe we use 10 milligram of gold. Down the track, maybe like the mobile phones, they used to have lots of metals, quite high amount. Now the technology they are going down because they want to reduce the cost, they want to technological advances. That number one. Second one, this reserve assumes what is currently explored. So, but exploration also changes every year. Like, although it's unlikely that in Australia, Pilbara, which is our iron capital, iron province, it's hard to get Pilbara like that because we have done a lot of exploration. Particularly in Australia, we have done a lot of exploration. In India, maybe not exploration is not there. Exploration, right? That where the material is, and how they deeply know that material. So in India, maybe some surface exploration happened, but maybe some mountains, some areas not explored properly. So that will increase the result. But to be honest, very unlikely that results like nowadays, big result, because this is already grade is declining. Already the resource finding chance is limited unless you go, and that's why people are talking about, I have some association with, one of my colleagues involved mining the moon, mining the sea. So there are so many things going on, but I sometimes say it's hard to mine in the land, and we're talking about the moon, how we get the material, and most of the mineral processing requires gravity. Moon doesn't need gravity, so yeah, anyway, that's another discussion. So, but people need material. That's the bottom line. And we are certain rate we are extracting this, and it will last certain times. And you can see that when iron 56 years, according to current situation, no more iron. So what will happen with the children and grandchildren and etc. So that may be recycling, that your electric arc furnace, which is other scrap maybe. So that's what, with the same thinking, we are applying for hydrogen technology. So are PEM electrolyzers recyclable? What recycling technologies are available? So that's discussing with that. So we did quite a bit of review, and actually we are going to do some work here. So if we look at quite a bit of diagrams, electrolyzer, you have to end of life, particularly talking about certain years it finished, its life is done, you've done some repair gone even, and then collection. So you collect it and then you dismantle it, and so basically electrolyzer stack is the main component you are after. MEA, so this is the membrane electrode assembly, and then how you, because that's the major catalyst is there, you take the catalyst out, and that's the metal, the precious metal. And you delamination, and you kind of resolution, alcohol resolution. So that one, you can do that one. And then, but here, before dismantling, we can have some some end plates, bolts, current electrodes, etc. This is major metal. Copper and steel, very easy to collect, and they are low value. And then bipolar plates is also platinum, coated platinum, which is expensive. Titanium is relatively expensive, I would say, and gold obviously. So that's, I believe that hydrometallurgical technology, and that's more pyromet technology, and that's kind of here when you got that sort of stage, and then you go sort of selective various types of metallurgical application, mostly in combination of hydrometallurgy, pyrometallurgy, electrometallurgy. So you make the crushed material, put some solution or some chemicals, some reagents, and get it out and refine. That's the way. But the problem is that because there is small amount, number one. Second one, some of the materials very similar. So more and more steps required to refine and make kind of a refined product. Because ultimately my objective, if I get that iridium or ruthenium, I have to get exact purity so that I can put that in a new electrolyzer, right? So that's the challenge. So these are the various products, so you can probably recycle, and that reduce the cost, number one. Second is that solves the problems of material issues that are discussed. We are talking about gigawatt scale, huge amount of electrolyzers, and already that so that some countries have targeted that many electrolyzers they will produce. Now where the material will come from, if you can recycle and give it that one, so maybe that will solve the immediate problem. Otherwise, I don't think there will be an industry in the long run. So let's look at membrane electrode assembly itself. So you delamination and then ultrasonification, kind of that different technology. You can centrifuge it, and you can kind of dryer and you get platinum and carbon catalyst. And membrane generally not very valuable material. Iridium, so mainly the catalyst and those precious material is the target for this kind of, and that's PEM technology. What about SOE? What about alkaline electrolyzer? Not much really, but PEM, SOE and PEM, one of the problems these two technologies uses specialized material, expensive material, and how we replace that or how we recover that. That's why we are pushing this area.
Is there any calculation that how much material reserve world has to make electrolyzers for hydrogen?
That's where been lots. Nowadays it was not there, but let's say last 1 year, 2 years, lot of documents like that, because the policymakers needs to know that one, and
Yeah.
coming out, yeah, so exactly how much material, so that's depending on, you know the loading, right, you know that one, you put those in that calculation, and you say that you want to do that many gigawatt electrolyzer, that is actually our organization, we have another unit, they do this kind of calculation, and their reports are available now, yeah. So you have got that now. If you are interested, just you can follow it.
Because we are calculating the reserve of iron, so we need to calculate those metals also.
Yeah, sometimes a lot of metal business people, they don't know, you know that we are talking about regular application of construction, etc. But the new technologies, there is huge demand, you know, wind turbines, you know, and we have a role to play also, that metallurgist or metal business, yeah. So that catalyst generally leach chemicals, as I said. So this is like oxidizing agent, nitric acid. It's a strong acid generally, or hydrochloric acid, and then you get filter it, and you get complex solution, and then you get solvent extraction, precipitation, and finally platinum powder. You can add some ammonia oxide, I guess, hydroxide. Similarly, that way you can do platinum powder. But ultimately, problem is lots of chemicals. Generally, it's a biometallurgical process. Sometimes you can add also the temperature to accelerate the process. Similarly, pyromet, so you dry it at 80 degree, 3 hour calcium. Actually, we are going through these experiments now. Leach, purify, reduce, and then finally the pure platinum. Actually, some of the information I found that report that you know that platinum also used in the exhaust or what they call that fuel, and that in UK I heard that from tailpipes that was in the road is swept for platinum recovery. This platinum is very expensive. I don't know how effective that is, but so in here we find generally here, so you are metallurgist, so hydrometallurgy, pyrometallurgy, and another is transient electrometallurgy. So I'll tell you about that. But before that, I mean that reminds me when I was in Korea, you know, LG, Samsung, big companies. So they produce all electronic goods. So I had a company called Sangil High-Tech. So he was very close to me, the owner. Actually, Korea worked and Australia worked a very long time. So I made a presentation like this, that how long material will last, etc. And then there was a tea break, and then someone came to me and asked me that, Doctor, can I get your presentation? I said, yeah, you go ahead. And his English is not very good. And I said, what do you do? He said, I'm owner of a company. And I said, what sort of company? He said, I do recycling business. And that time it was $40 million US value. So his turnover. So I said, interesting. So he said, Doctor, if you come in Korea, let me know. I will show you around what I do. Then I was going next year, and eventually I communicated myself and my colleague. And then there was an Incheon airport, Korean capital, Seoul is Incheon airport. So I decided that one is business that time, but this one is going to grow now much more. And we still have connection because I do other work with him. So that time that owner took me, Koreans, you know, that fine restaurants, he took me, and lots of curry, they give various types of result, table full of items. Anyway, interesting that then went to the shop, only the plant, and he was showing one after another, a room like this, full of gloves, hand gloves. And then I just asked, what's this for? He said, I'll show you what product we made, doctor. So I said, okay, let's do that one, and going through that one. And he said, silver plates and silver various items, it should be maybe small silver also gifted into. So but I said, where that comes from? You saw that glass in the room. So what they do when the workers work, they put the circuit boards, etc., etc., a little bit silver, a little bit other items get attached. So they take that, melt that, and then recover silver. There are many steps obviously silver recovery, silver solvent extraction, etc. So I was amazed that that's one of the example. Koreans, they don't have much resources, and that's why when I saw that London roads are swept for platinum, I said maybe that's true. So in Bengali there is a saying, isn't it? There's a kind of so if you get some ash, just wind it, and then you can get something valuable. So it's a similar kind of situation here. So those metallurgists, we know that hydrogen, pyromet, these are the two main methods. One is using acids at low temperature, other using temperature, so high temperature. So I didn't know what is the electrometallurgy particularly transient. So what they say that because it's the material is very similar, you need to have electricity and the pulse up and down, and that way you can separate and recover and refine the lithium. So essentially hydromet, pyromet, transient electrometallurgy, and you combine them to recover. So I think that selective electro chemical resolution, so ultimately you get pure platinum. So platinum recovery is quite laborious and lots of steps. So I think, so what we will go from there? So I think in terms of work, we are going to do some experiments and hopefully that will tell some. So we have done reviews. So not this is PEM electrolyzer. We have done similar thing for SOE. So I have got the same and we published it quite a big review program that what is in SOE, how much material, and there is a company outside China, that company is the largest rare earth producer at the moment. So 80% China produce now, maybe 70%, 10% comes from Myanmar, which is again Chinese control. Rest 20%, a company called Linus Corporation, and they have a mine in Western Australia, it's called Mount Well. So they produce rare earth oxides, and they are very interested about this sort of work, and we are working together because this Linus, what they have a mine in Australia. They take the materials to Malaysia and process for their further their processing. So they are very keen and they know exactly, they know much better than that from a commercial point of view. So that's why they give some intelligence in that sort of area because we collaborate and what is kind of what material is here, what material should target fast, and what's the value and what's the purity. But ultimately, so what we're doing is we have got electrolyzers, PEM electrolyzers, SOE, we are running that long time, we have lots of end of life. So what we'll do is we'll smash them, we'll grind them, we'll do that, what's the recovery possible, and what is the specification of the recovered material, can that be used directly in the process in the future. So I think that, but ultimately that needs also experiments, because that's anything, the same with the mining industry. Deposit in India, one of the mining industry told me that yesterday when I was visiting Ahmedabad, I asked the same question. We have lithium detection system in India. Apparently, because lithium is a kind of a predictable that apparently it's hard to detect. So one company they have given a lease or they have got that bought that deposit, assuming that there's lithium 200, I don't know, 2050 or something like that, but that has been tested from what they call surface exploration. They don't know actually just from the surface, maybe some sensors tells this may be possibility of lithium. They buy that one and now they drill it, get the sample, test it, they characterize it essentially how much lithium, what's the phase of that lithium, what minerals and how cost effectively you can extract that, and then whether it is making money or etc. But if I take them to Australia, they approach me through another colleague. It's very expensive in Australia. I said, you should do someone in India, see whether you can develop that story. But he said, oh, there is no one can do it here. So I think locally, I think what colleague was saying that maybe they are developing those sort of detection technique so that local companies can exploit that resources. So
how do we analyze lithium acidic?
So it's in Australia we have a big lithium team and we have invested, and that's the world's unique capability, one of the best I would say, specifically can detect lithium. So we have got other techniques, what is called XRD, one is called EPMA, electron probe micro analysis, EPMA. So EPMA is kind of, we have got EPMA, so in our facility, microscope, SEMs, etc., all is there. But you can buy also equipment like Hitachi and etc. You can see things, but what we have got here, those companies have got software libraries, and we have got 40 years relationship. So we probably that library is developed by some of our colleagues, and we give that access. No one has that one. So that's the way. So because I asked my colleagues, experts, those who are expert in characterization, why do you claim you are unique or you are the best in the world? He said, this is the reason we are the best in the world. And then, there are laboratories around the world that you can do that testing or characterization for money. Generally, if it is simple resources, you can. But if it is very complex resource, if you can analyze that way, it's hard to do that. So our role, we take those sort of jobs, it's very challenging because it is difficult to analyze, so that slowly we develop our own studies. So that's how the techniques has been developed. Does that answer the question?
Can you spell it? Spell the name.
EPMA.
The one you have.
In Australia, so it's a, we call it unique characterization facility. So so we call it CSRO characterization unit essentially, mineral characterization facility. So analytical techniques, various, it depends on, depending on materials, they use number of techniques together or one technique, another technique, and they try out and they meet.
A lot of interesting studies about how you
Develop.
put XRF on a drone and you go and see
That's
what
right,
exactly.
nowadays.
The state of the art.
Yeah, you know, there are, I don't know, 4,000 minerals or 3,000 minerals in the world. So at least, I guess 20 minerals named after scientists in that lab. So they are very good at that. And if you go and CSR in the wall, everyone's name that rhodocite or greite, so their names minerals. Very, very good scientists there. Yeah. So experimental technique, as I said, is study the efficiency, investigate the performance, and exactly any mineral deposit we have, this is the flow chart we follow. So you take the sample, characterize it, test it, get some data, develop the flow sheet, do the technoeconomics, do the LCA, and then say it's a business case and get the investor. And once this is a kind of business case, we give it to someone else and let them make money, and that's our job done. We need another project. That's a typical kind of cycle. So I think I wanted to talk about this kind of recycling aspect so that you know A to Z of hydrogen technology. So you know that technological equipment required, you need lots of materials, and obviously material recyclability important. So that's probably finishes everything about hydrogen. So happy to answer any question, any comment or a suggestion.
Sir, recently in the news, I heard that lithium reserve was discovered in Jammu and Kashmir. But after that,
No news.
no news.
Rajasthan also.
Sorry,
Rajasthan also.
Rajasthan. Jammu and Kashmir, I remember, lot of reserve was there.
So this sort of news we follow also.
Yeah, after that,
What happens, you know,
no media cover.
sometimes it's a bit hype, you know, hype means maybe there is resources, but any mining industry, Australia, that iron business, that started in 1960s, you know, and then maybe 2000, even maybe 80s, something came as a business. So mining industry is a long game. So you may have something, but you don't know what form, how easy to extract, is it mineable, you know?
So how it was identified? Like
Initially
yeah.
they do lots of, I'm not an expert, but they call it a lot of geophysical tools they use, maybe, I don't know what is radar, something like that, or some other some surface. So from the surface they will fly a drone or something, and they will get the magnetic sample, magnetic responses, and etc. They record it and they analyze it. Okay, these are the spots, maybe potentially some metals are there, and then they pinpoint what metal, and then they say, okay, this area may be potential area for exploration. That's how narrow down. And once it's real narrow, and they know that one, they call it, you know, in mining industry, I'm not also mining engineer, but they have got resource classification, okay? Reserve, proven reserve, what sort of category of that resource, and then finally becomes mineable, actually valuable material. And if you go to the bank, they will know that there's a code called JORC code, GORC, Joint Code Reserve Committee. They used to call it, now they call it minerals valuation. I don't know, India follow probably, JORC code is Australian one, but globally that's one of the very wide accepted technology or terminology or standard to say a minerals is credible. Another South African one, there is another standard. So mainly these two standards are used. They are very important in the stock market because if you want to start a mining, you need to raise money, right? And people will give money based on that, how good your resources are. So that, and not only that, that must be certified by OZIM. You know, I am the fellow of an OZIM. So you have to be a member of that OZIM to certify that. And even not everyone can do that. Some courses have to do. This is quite a specialized club and field. So So that minerals, when you find it, slowly, progressively you get the credibility of that resource. To do that one, you have to drill lots of samples. So more sample you drill, it becomes more credible, right? Initially, but drilling sample is expensive. You have to have so maybe have 5 kilometer land, you got your tenement, and you buy from government or lease from government, Ministry of Mines or someone, and then because they know that one those material may be there, and then you need to drill, and if you have say 100 drill initially, maybe 1,000, maybe 10,000, so you have a precise number, and then use that drill codes to the lab and see that whether lithium is there, whether other minerals is there, etc. So CSR has got a technology called high logging. So essentially it's a drilling system, the camera and sensors on the drill tip. As we go drilling, they record number, computer, that can analyze and say, okay, this this one, maybe that layer in the ground, underground, maybe is a good level. So there are a lot of sophisticated modeling also nowadays. It's a very well advanced kind of discipline. So in India, and not only India, I've seen that some other countries like say North Korea said that we have the largest layer of resources. But you can say that one based on some initial understanding. But ultimately you have to drill hole, have to analyze, and then they say that one, is that nearby kind of town where you can, because you need people to work in the mine. You need to extract the material. Is there a railroad? Is there any shipping? So all these things put a project as a good quality. Okay, then people will come and invest. Okay, this is the money, this is the mine, and you make money selling the product. It's a bit long answer, but does that answer your question?
Yes. Maybe Venezuela also there's a lot of oil reserves, but maybe they are not exploring.
Yes, same way. So usually these sort of resources, oil, gas, minerals, kind of similar, but each of these products is different, So that's why their exploration techniques are different. And even between metals, they vary a lot. So anyway, my background is not that. I just what I got from my colleagues. Any other question? Comment. So I want some honest feedback. How do you find out the overall last 5 days, 4 days? Your satisfaction level is it, I don't know, 5%, 10%, say more than 50%? I'm happy that more than 50%. So it's a new, not new.
Not new, but it's a laborious consolidation of a huge amount of kudos to the patients. Rather, I would not have preferred to compile once a week, maybe I would have read just like that. But it's a huge effort that has been put bringing it to service modules and giving it a shape of a course. It's a great effort and it's very useful.
Thank you. So I think
And also since about 2 decades data has been showing and we appreciate the work.
So just I share my experiences essentially and try to put them in a context as much as I can. So hopefully that has been useful for you. And yeah, but it's not necessarily that you are taking the job it will be useful, but overall as long as it's useful, that's how we. But I think as I said that maybe students, because this kind of not new areas of research, higher studies, things like that, so they get more interested, excited. But operational people, I find it
more data on the country, Indian content
could be useful.
Could be useful because the data showed regarding India is very old, 2014, 2015, 2009, some data. So latest data will be more useful, but overall you get to know many things, maybe superficial some of the things.
So hoping that someone in India takes that job and delivers the data, because data is very important.
The research scholars can update the data in the latest
Kind of work that sister has done in Australia, I think the Indian government should
invest.
look into this kind of work and put more effort into the R&D so that the newer technologies can come up. In the near future, we have chemically decarbonize the entire steel making process.
Yeah, I find some people say that government is giving a lot of money, there is not people to take that money. Is that true or does not?
This
So see, these kind of efforts, I believe, mostly government driven, because we can't expect the companies to change overnight, right? So yes, work is being done.
Yeah, it's like chicken and egg.
yes, it's like chicken.
Industry has certain expectation.
Yes.
Government has certain expectation. Both.
Industry will come only either with a stick or with a
It
profit.
was already been solved few months ago. Yeah, the answer is chicken. Again, this is what solved.
Actually, within LCA, there is a concept called weighting. I didn't go too much into LCA. So weighting is that when you have that kind of analysis, then you put, for example, what I say that you go to the industry that generally it is government. So you put 100% weight, 100%. So 1/3 maybe economic, 1/3 social, 1/3 environmental. Because government view is balanced. If you go to industry, what do you think? That ratio?
Yeah, mostly economical.
99%. And if you go to say non-governmental activist and environmental organization, what will they do?
Because they mostly will be environmental.
Yeah, so that weighting is subjective.
Yes.
That's why it's a little bit tricky there. Sometimes you do
There
weighting.
should be some
So
guidelines.
individual ministry should take up the issue that we have to improve our environmental cases, because they are doing a lot for the social. The PSUs the government has done for the social. The environment has to take priority.
So my feeling is that when you say that companies are only for profit, that's not true.
Not only,
There's also a lot of
but
social things.
Corporate social responsibility
CSR is there.
is there, but no environmental policy.
But another thing I noticed that India, CSR is more about helping charity,
Helping school, helping
not so much on the CO2 or something
Yes.
like that, less on that.
Not in the environmental concern.
I don't know, did I ask you how many mobile phones you have used?
Yes.
So that kind of, I don't know, here mobile collection system is there or not? No. So do you think that company is going to force the customer says something, they are going to listen?
Definitely, because if a customer asks that I'll give a premium amount for a green steel or a less amount of CO2 generated steel, then obviously the company will shift in that direction.
So sounds like customers are not educated.
No, because see, for steel industry, the cheap steel is easily available.
Available.
For the customers, the cheap steel is easily available. So why would they pay a premium?
There's so much competition.
Yes.
China is dumping.
China is dumping,
South
then
Korea is also dumping. So why someone would pay a premium?
Cost is very different. Everyone wants
Cost is the
the
only way.
cheap steel.
Until some environmental regulation is there.
Yeah.
Unless and until there is a clear directive.
Clear guideline. You have to produce some amount.
Next 10 years.
Yes, there should be compliance.
Otherwise, this cannot be
Like government projects and housing projects.
Like in one of the articles you showed regarding India, government says after 2030, 37% steel will be green steel purchased by the government. The government projects the steel.
Then that will force.
Yeah, then it's a force scenario.
That kind of compliance is necessary.
It is 30%, 40%.
Do you think that is government decides based on the people's votes? Isn't it? Not necessarily they come out something unless people want it. So it's a matter of the awareness of the society, right? That's
but that is never an election issue, right?
Suppose my
That environment is not an
they will take it for 5,000. So
yeah, I think that's
But see, like in our case, when plant is coming up, so there should be clearly mandated that we need to use a dry GCP, the nuclear gas cleaning plant. It was wet previously. So that was a mandate, but the mandate was never that we need to go for say dry SGP.
I think let's finish it another probably 8 minutes. I have to go. But what I'm going to each of you, I would like to say that you tell what you wanted to learn but or wanted to know from a course, but I didn't cover at all. At least I have in the future that these are the needs for the people. So maybe we start here. So what, say, 4 days we spent together, quite a bit of time, we were talking there. So what you wanted to know, but you didn't get it.
I wanted to know what is decarbonization related to power sector mainly, because I am from power sector. Or more specifically, because about the power sector, mainly
Steel or metal based device, you had as well power. Power would be better. Yes. What about you?
Yes, sir. Something like we are power sector background. That's why we need also reduce the carbon emission.
The power sector.
New technology will reduce the emission. Mainly the covered in the steel sector. But overall, the scope is very realistic. What is going on in our future? We are thinking about 2100 to 28. That's why it is for me. It is very
Thanks. Thank you. What about you?
So, first of all, the answer was very good for me. But I thought about some internet training on Cypro and LCA analysis, footprint analysis. As we mentioned also in the video, but we will go through the YouTube videos of Jian's course.
There are a lot of videos available. And software, you have to train yourself.
Yes.
Nobody is teaching.
Yes. That's
Thank you. So, similar.
more hands-on training or a case study basis training or a small LCA calculation
That
or
would be
more that would be very good. So you can take this forward with more complex.
Next advanced system of
Yes.
Actually, I sometimes student project when we develop together, we put a group and team. Then we do LC and we face difficulty, and then that comes in a bigger kind of project like that.
As an example, as you mentioned, the example of a tree in wooden house, I guess, wood shade. For the LCA wood shade, if I can able to calculate the LCA of the wood shade, that will be very good. That will be a complete understanding of the LCA. Absolutely hands-on training on small case study basis like a wooden shade or a car or a cake like this. So we can go it forward to the steel or the aluminum or anything else forward.
So you can also online, there are nowadays people offer advanced LCA training. There will be probably, but generally not many trainers available. So
Was it anything from a particular institute or
that's for life cycle strategies. One company in Australia, they do that.
life cycles?
Strategies, life cycle strategies. Maybe at $2,000. Also MIT has got. MIT is very introductory.
Is it online?
Online. Alright, what about them? What
Actually, same as I said, I am also
Power industry.
and I also wanted to learn something about decarbonization related to power sector, and especially how to reduce the emissions
In the power sector.
emission in power sector, and also I wanted to know if there is some change in resource, we can replace the resource that is our main resource is coal. That total replacement of that is right now impossible. We have replaced 5% with biomass in the previous 2 years, but that is not very much feasible because biomass is not very much available, and also handling of biomass is too much. It is very hygroscopic and several problems we have faced. So I was focusing that if I can get some ideas regarding the replacement of and get an alternate resource that can be so that we can reduce the amount of coal and replace with something else.
So when you say we want for alternative technology, that's keeping your current system as it is or completely switching the system?
Because completely switching right now is impossible.
Okay.
Because all of our power plants are coal based.
Right.
So completely replacing it is just now impossible. As they said that completely replacing the blast furnace is
Not
not
possible.
feasible.
So you want to
right
do
now-
something within what can be done?
Within the system, and our management will ask regarding that only. If I offer an alternative solution, that is
They
not
won't-
acceptable
they are not
at all.
after
That
that.
is not listenable at all.
Right.
So we want something that we can do in this system.
So maybe energy efficiency auditing, something like that you can do easily. I don't know. Maybe I have no idea.
Energy efficiency see auditing it is we are doing and we are trying to reduce the
But that does not much.
but that is not the practical way we can practically we have to change the source. We have to eliminate the result.
That's coal, how we replace
Yes.
or do something with coal.
Yes.
Yeah, so there are some people who talk about clean coal or coal treatment, oxidable combustion. I'm not, because I'm not in that deep into that area, so I couldn't share much. Anyway, so at least I know that what you are
But
after.
I have learned several other things.
Thanks, thank
That
you.
is also
Only the hydrogen scenario of hydrogen.
Yes.
What about Nepali? What you wanted to learn but didn't get here? That's what I want to know.
Actually, I want some knowledge in reduction of CO2 emissions in thermal power.
So that's very obvious. Looks like that's the.
But I have got some idea regarding LGB is the solution. But it is what we can include that the green hydrogen. But in our thought that hydrogen seems to only for generator cooling.
That's all.
And the amount is very less. So hydrogen production is not feasible here. So I have got another idea. Complete.
Thanks. Thank you. What about you? Anything new?
Sir, I was also expecting as per the topic decarbonization. So I was thinking that in our power plant, what we can do or what are the new technologies coming up, especially in this perspective, that we can reduce the emissions, especially CO2. Yet now we are not doing it. So I was not aware of whether is there any some technologies coming up or we are or government is planning to do so in near future. That kind of thing.
Maybe in the future we have to think there are not many solutions, but maybe drastically something radical we will think about. Yeah, right? What about you?
As per me, the overall session was good. It explained me about new technology, hydrogen. As I belong to industry, and no industry wants to increase the cost of production. And a small change needs to be widely thinkable for the management, like introduction of the we are trying for biomass injection or something like that. So it needs to be to make the design into a new construction to design the furnace or design the pipeline, something like that. But the overall technology with hydrogen, I don't know in India when it will be coming to the industry, steel industry only. But the knowledge we have got from this 4 days, it's overall good with the new technology with hydrogen and the types of synthesis of from with hydrogen, and the overall program is good. Thank you.
Sorry, already gave it, but anyone will say. Otherwise, you did the LCA course, right?
So the course is really good because you get a lot of overview of everything. But I need this course in depth if it is possible.
Did you, after that course, did you try any project with yourself?
No. I didn't get time because my
Yes.
time,
Maybe you need to think about that advance, some work yourself.
Exactly.
Best option you do it to learn about LCA. I say, student,
practice.
do one yourself. That's the best way to learn. What about you?
Yes, sir, it's very effective, sir. It is very helpful for my business topic. And also, I'm thinking like using this Schema Pro software, either I can use like OpenFCA by HSC. I'm planning which one is very good. I'm also
Have you used it or not?
supposed to use, sir.
Yeah. Try. I think it will be. Just try. Yeah. See how it goes.
It is very helpful. Like most of the people, they are doing research only, but this LCA is very useful for all the CO2 emissions coming from the initial to final. Then you optimize the entire process. Can make like to improve the general impact for research.
I think anybody in research, because you are new technology development, good understanding of LC is important. I think that's why a lot of people learn to evaluate their own technology.
It is very good, but Indian scenario, it is already blast furnace is over the life is there like up to 2040. So,
but you are going to propose a new thing, then
Yeah,
obviously that
yes,
has some
yes.
evaluation required. That's what I'm saying.
It is very
Thanks a lot.
scenario.
The overall course is very good and data is very good. But if you provide some updated data, because of the almost all data is 10 years, 15 years back, so we can get a better scenario of the current position. But we can get it from Google or anything. But overall knowledge and everything I get very good.
Thanks. And I think in the back, probably, if you say what you wanted.
Good, it was we learned a lot. We have become a better informed students of decarbonization and hydrogen development in our country. It was a very learning session for all of us. What was lacking was the things mentioned in the module. So it would have been more in detail, like
Technology side.
accounting technologies.
How technology is moving forward in terms of power industry or steel industry.
Where it has been implemented, what can we learn from it? How can we implement it in our respective workplaces? That kind of thing. But overall it was good.
I can think about that who are the experts in that sort of area and connect with energy or if there is a training coming, whatever you, I mean, commented quite a bit. Also,
It's a nice session at least. We came to know about the hydrogen. Like, what are the different scenarios we are thinking? The world is thinking. The world is thinking how to use it, first is how to produce it. So, and before that, we heard about the hydrogen, but not the uses of hydrogen in various fields. So that we came to know. I am not a metallurgist. I am a electrical person. So I came to know a lot about the metallurgy in this session because I am in steel plant. I know bits and bits of process of steel making. But here in the 4 days I came to know a lot of in-depth knowledge of the steel making. It will be better if we get to know that what we can do now in our industry to reduce the carbon.
more immediate
Immediate
solution.
solution. But it's not available, I think, in the industry right now. It's far away because our industry is not a small thing that we can change in 1 or 2 days or 1 or 2 years even. Maybe next 10-15 years it will be important for the steel industry in India. Because if there is a new installation coming because of the government thinking for the steel production boost, maybe some major giants of the steel making, they think about the new ways to make the steel. If it is possible, DRI route is one of them. So we can have the thought process. In future, we will see what happened. Because many things comes on paper, but not on the reality.
It's a very good topic for Dr. Arun. What is the immediate solution for them to get something tomorrow? I need yesterday, not tomorrow. Yeah, I know industry is always like that.
And thanks to you, came a long way to teach us. It's a great opportunity for us because we are in industry and after 15-20 years we are in the classroom. After the college.
Thanks for that.
It's not easy.
I learned a lot from you too. I guess it's not necessarily, so thanks a lot for that. You?
Yeah, we had an enriching session last 4 days. Learned completely new things like LCA. I had no idea how to calculate this kind of things because I'm a process guy. I've been last 15 years I've been involved in blast furnace. So learned LCA, learned DCWW, and completely new technology, the hydrogen, how to use it, how to produce it, what is the cost involved in it. Yes, the sessions were very enriching for me. If you ask me what I wanted more, maybe more of how to decarbonize the blast furnace because I'm in the blast furnace and the real challenge is to decarbonize it and ultimately the footprint of CO2 reduction. Yes, because more in-depth analysis on blast furnace, particularly in iron making, would have been a little more helpful. But the overall session was great.
Thanks. In the back.
So overall the session is very, it's quite informative. And so much new things to learn, sir.
Thanks, I think, thank you. And the main issue is that, yeah, I do this kind of things, and at least you know me, I know you. In general, even some information we share with each other, make friends, obviously, that, yeah, I'm connected with, people connect me with LinkedIn, and by any chance, if you come to Australia, for whatever reason, just let me know. I will spend some time with you. And maybe some of the needs, I know that, yeah, because my expertise in LC and hydrogen, maybe expectation is that it's a little bit different. So, but overall, at least you have got something out of it. That's I'm happy that, yeah. So in the future, maybe there will be real dedicated training just for power station or just for steel mill. We have some other resources we can dedicate that. Yeah. So I think that's it, Dr. Raru, and thank you for your time. And I know it's of course it always comes with a mindset how it is and unpredictable, but yeah, that's what it is. What it is. We have finished.